Hello, welcome to Unit 5. We're going to do more work with derivatives. Day 1 is we're going to add another derivative that we haven't learned yet. So like I said, we are working with derivatives. These are all synonyms for derivative. And let's look at some of the rules that we already know. And we know this is the power rule. So you better know how to rewrite things. You better know that a over x to the n is equal to ax to the negative n, and that's a times the nth root of x to the m is equal to a times x to the m over n power over root. You do have to rewrite things. Next, we're going to look at our trig derivatives, and I have this unit circle over here, and when I go clockwise, these are my derivatives. So the derivative of sine is cosine, the derivative of cosine is negative sine, and negative sine is negative cosine, and the negative cosine is sine. And the lesson that we learned at the end of the last unit was very easy. The derivative of e to the x is e to the x. I also talk about this all the time, is that coefficients get a free ride. That if I put a coefficient in front of something, it just goes along with the whole derivative. It's not too hard. The derivative of 5 sine of x is going to be 5 cosine of x, so on and so forth. This you have learned before. This is not too tough. Remember when we subtract 1? So if I have a fraction, if I have my exponent is a fraction a over b and I want to subtract 1, it's always top number minus bottom number over bottom number. Okay, and we've talked about this many times. So today we're going to add a new derivative that we haven't learned before, and we're going to look at the function y equals the ln of x, the natural log of x. And if you recall, it goes through 1, 0, goes through the point, well, since the base is e comma 1, which is like 2.7 comma 1, you kind of have this curve, this graph that looks like this. This is y equals the natural log of x. But I also want to incorporate the idea of the absolute value of x. So when I have negative x values, I normally can't take logs of negative x values, but I can if I do the natural log of the absolute value of x. And it's just going to be reflected on this side of it, and it's going to look like that. So this part adds the natural log of the absolute value of x. So now I want to graph its derivative. And if you recall, when I do a derivative, the slope from these graphs are going to be the y value on this graph. I'm going to shrink it up a little bit. And if I pay attention here, this slope, let's look at the blue graph. This slope here is very large. It's like almost infinity. This slope here is maybe about 1. And the farther I go out, the slope gets closer and closer to 0. Well, on the other side I have exactly the same thing. This slope is about 0. This slope here is now about -1. And this slope here is going to negative infinity. So if I draw this graph, it kind of looks like this. Right here about 1. That's the derivative of the blue side of the graph, and here is the orange side. So this graph is the derivative of the natural log of the absolute value of x. And if you recognize this graph is y equals 1 over x. So we have learned that the derivative of ln of x is 1 over x. We call it y prime. We call it y prime is 1 over x, or dy or f prime is 1 over x. And if you put a coefficient up front, it doesn't really change. It's just going to be 5 times 1 over x, which is 5 over x. And this would be a over x. So this is a new derivative that we have learned, taking the derivative of the natural log of x. Okay, time to do some examples. This one's pretty easy, just a regular polynomial. So f prime of x, don't forget your notation, is equal to negative 10x plus 36x squared minus 5, 6. That one you should be pretty comfortable with by now. This next one, I better rewrite it. I do not like this guy, and I don't like this guy. So I better rewrite it as 12x to the negative 3 plus 5x to the negative 2 minus 5, 6x to the negative 1. Now I'm going to take its derivative, g prime of x is equal to negative 36x to the negative 4 minus 10x to the negative 3 plus 5 over 6x to the negative 2. Sometimes you have to rewrite things before you can take its derivative. Okay, this next problem, I don't think I have to rewrite it, so I could just do f prime of t equals, let's see, multiplying these two, I get 6t, 3 minus 2 is 1/2, minus 8 over 5t, top minus bottom is negative 9 over 5. Derivative of sine is cosine, so plus 6 cosine of t. Next example, again, g prime of x equals, with the derivative of cosine is negative sine, so it's negative 3 sine of x, plus, well, we just did this, so this one's going to be, the derivative of ln of x is 1 over x times 2 is 2 over x. Problem number 5, I probably should rewrite this problem. X to the 1/2, and then just minus 4 cosine of x, and when I take its derivative, I am over 2, x top minus bottom, negative 1/2. Derivative of cosine is negative sine, so it's going to be plus 4 sine of x. Same thing here. I should expand this, and I got to do it twice, so I get 8r to the 12. So my derivative of this is going to be 96r to the 11. For this next problem, I should split it into 3 fractions. I'm going to split it because they're all being divided by w to the 3rd power. So when I rewrite this, w to the 5th minus 3 plus 2w to the negative 3. So now when I take its derivative, 5w to the 4th the derivative of 3 is 0 minus 6w to the negative 4th power. Like I said, sometimes you have to rewrite things before you can take its derivative. Take this next problem. I'm going to rewrite it. X to the 3/4 power over root. That one I don't have to rewrite, and this one I don't have to rewrite. Now when I take its derivative, well, I get 18 over 4, or what I call 9 over 2, x top minus bottom, negative 1/4 plus 8x. Wow, that's maybe 8, taking that like that. 8x to the negative 1/3. And the derivative sign is cosine, so minus 9 cosine of x. Like I said, you really need to know your rules of exponents so you can rewrite things. So I'm going to rewrite this problem. So I can take its derivative. Derivative e to the x is e to the x, and there's a negative 3 in front of it, so it just goes along for a free ride. Pretty easy problem. In this last example, I gotta rewrite it maybe a couple times. This is x to the 4th, this is x to the 1/3, and I have to subtract exponents. So I'm going to do 4 minus 1/3, so I get b of x is equal to x to the 11/3 power. And I could just rewrite the rest of the problem. Plus this big old constant at the end. Now when I do b prime of x equals 11 over 3 x to the 8 over 3 plus derivative e to the x is e to the x with a half in front of it, so 1/2 e to the x. And then I have to do this term here. So the derivative of ln of x is 1 over x, so I have to do negative 2/3 times 1 over x, and when I do that I get minus 2 over 3x. So this last term here is minus 2 over 3x. Okay. Ask questions in class and work on your daily assessment. Thank you.